Ever wondered how the tiny camera inside your smartphone manages to rival bulky professional cameras? Today on Knowledge Hub, we're diving deep into the science and engineering that turn your phone into a photography powerhouse. At the heart of every smartphone camera is the image sensor, a microchip made up of millions of tiny pixels, each one responsible for detecting light. In DSLRs, these sensors are physically large, which means they can capture more light per pixel. Phones, on the other hand, are constrained by size, but modern flagships have turned this challenge into an opportunity with backside illuminated sensors and stacked CMOS technology. For example, the iPhone 17 Pro features a 48-megapixel stacked sensor where the photodiodes and transistors are separated into different layers. This design maximizes light absorption and reduces noise, especially in low-light shots. Meanwhile, Samsung's Galaxy S25 Ultra pushes resolution even further with a massive 200-megapixel sensor, which uses pixel binning, merging groups of tiny pixels into larger, virtual pixels to capture brighter and cleaner images at night. Then there's the lens system. Professional cameras rely on bulky glass lenses to manipulate light, but smartphones use miniature, precisely engineered lens stacks, often made of plastic or hybrid materials. Modern flagships don't just stop at one lens either, they pack an entire lens kit into a single phone. Ultra-wide lenses capture sweeping landscapes, telephoto and periscope lenses provide crisp zoom, and macro lenses reveal tiny details. Samsung's periscope lens, for instance, uses a prism to bend light sideways inside the phone, enabling true 10x optical zoom without making the device thicker. Apple's iPhone 17 Pro Max now offers a 8x telephoto zoom module that rivals DSLR portrait lenses. In short, your phone is carrying what used to require an entire bag of professional glass. But here's where smartphones truly leap ahead: computational photography. Unlike traditional cameras that rely purely on optics and sensor size, smartphones use powerful image signal processors and AI to enhance every shot. When you press the shutter button, your phone rarely captures just one image. It often takes a rapid burst of exposures in milliseconds. Apple's Photonic engine processes data from multiple frames, combining them pixel by pixel to preserve detail, improve color accuracy, and reduce noise. Samsung's Nightography mode does something similar, aligning dozens of frames to create bright, sharp night shots that look almost impossible given the small sensor size. Features we now take for granted: HDR, which balances bright skies with dark shadows, portrait mode, which uses depth sensing and AI to simulate DSLR-style background blur, and night mode, which reveals stars and cityscapes in near darkness, are all the results of computational photography. Even video benefits from this. Modern smartphones can shoot 4K and even 8K video with real-time HDR and cinematic stabilization. To make this possible, smartphone cameras use optical image stabilization, tiny actuators that physically move the lens or sensor to counteract your handshake. Autofocus systems have also evolved. Phase detection pixels embedded in the sensor, laser autofocus, and now AI-powered subject tracking ensure your subject stays sharp, even if it's moving. And let's not forget the image pipeline. Once light hits the sensor, raw data is captured in formats like RAW or HIF. Professional photographers love RAW because it preserves maximum detail and dynamic range, allowing deep editing later. Phones now support RAW capture too. Apple's ProRAW and Samsung's Expert RAW modes give users DSLR-like editing flexibility, while still allowing casual users to enjoy beautifully processed JPEGs and HEIF images straight out of the camera. Ultimately, the integration of hardware and software is what makes smartphones so powerful. Dedicated neural engines and AI accelerators inside chips like Apple's A19 Pro or Qualcomm's Snapdragon 8 Elite Gen 4 handle real-time image enhancement, noise reduction, and scene recognition. That's why your phone knows whether you're shooting food, a landscape, or a portrait, and optimizes settings automatically. So, While a DSLR still has advantages in pure optics and sensor size, smartphones have achieved something remarkable. By blending physics, optics, and computational power, they've put professional-grade photography into the device you carry every day. Whether it's Apple's seamless color science or Samsung's ultra-high-resolution zoom, modern smartphones prove that sometimes the smartest camera really is the one in your pocket. If you enjoyed this deep dive about how everyday technology hides world-class engineering, don't forget to subscribe to Knowledge Hub for more. And as always, stay curious.